behind me some important definitions and terminology for us to look at. And I'll also pull up the article from Khan Academy on solid geometry vocabulary. We're going to be looking at three different types of three-dimensional solids: prisms, pyramids, and spheres. I'm sure you've seen some of these objects before when you studied surface areas and volumes in your prior math class. I just kind of want to put some of these important terms and definitions back in your notes and in your mind. A prism is a three-dimensional solid that has two congruent parallel faces that are called the bases. On the screen, on the television screen, there are two different types of prisms. What are the bases of this first prism? What are the two congruent parallel faces? Is it the rectangles around it or the triangles in front and back? Triangles. We name a prism by the name of the bases, by the shape of the bases. So on that first shape on the screen, that is a triangular prism. The two congruent parallel sides are the two triangles in front and back on that shape, so it's called a triangular prism. I drew up on the board a prism similar to the one that's on the screen here. It's called a rectangular prism. What's unique about a rectangular prism is that the bases could be any of the sides. Go ahead. The top and the bottom could be the two bases because they're two congruent parallel rectangles. The two bases on the left and the right could be the two bases because those are also two congruent parallel rectangles. The two faces on the front and back could also be the two bases. Whatever you want to orient it, it's fine with me because they are always going to be two congruent parallel sides. So I could call any pair of opposite sides the two bases in a rectangular prism. Prisms are named for their bases. You could have triangular prisms. You could have rectangular prisms. You could have prisms where the bases are hexagons and have 6 sides. How about this shape up on the screen? Let's get your eyes up here. What are the shapes of the bases in this type of prism here? Circles. It's a circular prism. The two bases on top and bottom are both circles. In other words, it's a cylinder, like a pop can or a soup can. A cylinder is a circular prism. One of the more common types of prisms, a cylinder or circular prism. We could also subdivide prisms into either a right prism or what's called an oblique prism. Oblique, O-B-L-I-Q-U-E, oblique. In a right prism, the lateral faces, the sides of the prism are perpendicular to the bases. So this 90-degree right angle marking indicates that all the sides around the trapezoidal prism are perpendicular to the two trapezoidal bases on top and bottom. Basically, it's standing straight up, right? That right prism is standing up straight and tall, standing straight. An oblique prism, the sides are not perpendicular to the base. In a right prism, they are perpendicular. That's why it's called a right prism. In an oblique prism, they're not. They're leaned over somehow. This triangular prism, it's like the Tower of Pisa, Leaning Tower of Pisa. It's off to one side. It's not a right prism because the two bases of the prism on top and bottom do not form a right angle with the 3 sides around it. The big difference between a prism versus a pyramid is in the number of bases. A prism has how many different bases? A prism will have how many different bases that I underlined up on the board? 2. In a pyramid, how many bases are there now? 1. A pyramid, for example, is another three-dimensional solid that has one single base and triangular faces. A prism has 2 bases and faces, sides that are all parallelograms. A pyramid has one single base, and all the other sides are triangles. All those triangles meet at a single vertex point. This point up on top, this vertex or apex, is where all the different faces, the triangular faces of the pyramid, come together on top, the top vertex point. Just like prisms, pyramids are also named for the shape of the base. What is the specific name of this type of pyramid?
Square base.
Square, I'm going to call it rectangular. It's a rectangular pyramid, but I see what you're saying. You don't quite know that all four of the sides on the base are the same length, so let's just assume it's a rectangle to start. The name of this shape tells you what shape the base is, which is kind of handy. Once again, up on the television screen on this Khan document. These are also pyramids, but what shape is the base? Circles. So these would be circular pyramids, otherwise known as cones. Another example of a pyramid is kind of like a traffic cone, or a cone you could put water in from a drinking fountain or something. A circular pyramid, otherwise known as a cone. Pyramids, just like prisms, could also be right and oblique. A right pyramid is standing straight up and down. The base would be perpendicular to all four of the triangular faces in this trapezoidal pyramid. An oblique pyramid is where the pyramid's kind of leaning over. The faces do not make a right angle with the base. Prisms, two bases. Pyramids, only one. There's one last type of three-dimensional solid we're going to look at throughout this unit, and it's called a sphere. Like a baseball or a basketball, pardon me. A sphere is a two-dimensional solid where every point on the object is the same distance to the center. Kind of like a baseball or a basketball or the globe. It's a sphere. A sphere is a three-dimensional object where every point on the sphere is the same distance to the center. Every point on the surface is equal distance from the center. If I label that distance, let's put the center here in blue. I'm going to draw that distance to the sphere. What is that called? It has a specific name. It starts with an R.
Radius.
Radius. The radius of the sphere is the distance from the center to any point on the sphere. You can also describe a sphere by its diameter. A diameter is the distance across the sphere through the center. Diameter would be twice as long as the actual radius. Prisms, pyramids, and spheres. That's what makes up this unit. Prisms, pyramids, and spheres. What makes up prisms, pyramids, and spheres? What are the different parts of prisms, pyramids, and spheres? Up on the screen and on the board, I have the three different objects that make up all these different types of solids. Polyhedrons are made up of what are called faces. A face is a flat or continuous surface of a particular solid. Here on the screen, one of the faces is labeled in green. This cone actually has another face besides the circular base. If I were to unwrap the part that goes around the circular base, it makes another face of the cone. If you unroll it or unravel it, it'd be another surface of the actual solid. How many different faces are in this rectangular prism? 6, the 2 bases plus the 4 lateral sides, right? How about the pyramid? How many faces make up the pyramid down below? To get them? 5. The rectangular base on bottom and the 4 triangular faces around the pyramid itself. When 2 faces meet, it creates what's called an edge, a segment where 2 faces intersect. That is called an edge. A segment where 2 faces meet each other. Here's an edge of the prism, where the top face and the right face intersect. This bottom front edge is where the front face and bottom face intersect. An edge is where 2 different faces meet. A vertex of a three-dimensional solid is the one point where 2 edges meet. Where 2 different line segments or 2 different edges meet, it creates a vertex. How many vertices are there in this bottom pyramid? Look at the shape. How many vertices make up this different solid here? 5. The 4 for the base plus the vertex where all the different triangular faces meet on top.
Cylinder, how many vertices?
Cylinder would have 2, where the 2 bases meet the lateral face. Yeah. If you were to unroll a cylinder, it would look like that, right, Tristan?
Yeah.
So there's your 2 edges, or 2 vertices, pardon me. Vertex, point where 2 edges meet. How many vertices are there in the prism on top?
8.
Take it?
8.
8. The 4 around the top base and the 4 around the bottom base. All right. Let me pass out this document here. And could you guys get your laptops out so you can get on the Google Classroom? Now we've got a little bit of background in some of this important terminology. Our task today and tomorrow is to look at the different cross sections that make up these three-dimensional solids. If I were to cut a knife or cut a plane, a flat surface through each of these solids, what type of figure would it produce? Let me pass this out. We'll get on the Google Classroom. Yes, sir. Scroll down to where it says Unit 3, Solid Geometry. There should be a new assignment for all your Khan Academy practice, and then right below that is the Google Doc where I've got all these resources linked for you that we'll use throughout the class, throughout this unit for class. So click on this Google Doc here where it says Solid Geometry Resources. Find the link under In-Class Resources where it says Sections of Solids GeoGebra link. We're going to fill out this handout by looking at some of these cross sections on this GeoGebra link here. Once again, a cross section, if I were to just slice right through the middle, what type of flat figure, what type of two-dimensional figure would be created by taking the cross section of a three-dimensional solid? I've got that same shape or that same chart up on the board. Let's start filling it out. Pull up the same thing here. Looks like I've got 6 different rows, each with 6 different shapes. All of these columns ask me different questions like, what is the name of the figure? What shape is the base? How many faces does it have? What are the different cross sections if I slice it parallel to the base, perpendicular to the base, or diagonal to the base? What are the different cross sections that we can look up on that GeoGebra link? All right, that first figure, will you tell me what's the name? Cube. Let's just name them all. I'll go down the first column. Row 2. It's a circular prism, otherwise known as what?
Cylinder.
Cylinder. Cylinder. Row 3, the next one down below. This is an example of what type of pyramid. Name it by the shape of the base. Triangular pyramid. Prisms and pyramids are named by the shape of their base. Since the base is a triangle, it's a triangular pyramid. Awesome. Last set of 3. The one below it here. Is it a prism or a pyramid?
Prism.
Prism. What shape is the base? It's got how many sides for those 2 bases on top and bottom? 5. A 5-sided figure is called what?
Pentagon.
Pentagon. It's a pentagonal prism. There's a tongue twister for you. Pentagonal prism. Let's see, down below I've got another prism. What shape is the base here? A triangular, more specifically, it looks like it's a right triangular prism. The base is a right triangle. And that was a prism, right?
Yes.
Last three-dimensional solid. Looks like a pyramid. What shape is the base on the last row? Shape is that base? Rectangle. Let's call it a rectangular pyramid, similar to the one that I drew earlier. All right, column 2. We've already done a lot of this work because now it just asks us, what is the name of the base of each of these solids? Well, let's just go down to the next column. Start with the cube. What shape is the base?
A square.
A square. A cylinder has what base shape? It's a triangular pyramid because what shape is the base? A triangle. The pentagonal prism has to have a pentagon for its base. A right triangular prism would have a right triangle for its base. And the rectangular pyramid has to have a rectangle for its base. Why don't you guys take a second and fill in the next column? How many faces or sides, if I unroll or unbox all these shapes, how many different sides would be made up from it? How many different faces or sides make up all these different figures? If I were to unroll them, unbox them. So we can have, because it's got the 2 circle on top and bottom plus the 1 wrapped around it. All right, this should just take a second. Faces in a cube, how many? Faces in a cylinder, how many? It's not 2, it's actually 3. There's the 2 circles plus the one wrapped around them, right? For to lay it all flat, there'd actually be 3 different sides to the cylinder. The triangular pyramid has how many different faces? 4. The base plus the 3 triangles around the side. The pentagonal prism. 7. The 5 around it, plus the 2 pentagons on top and bottom. 7 total. The right triangular prism would have 1, 2, 3, 4, 5. And the rectangular pyramid has how many? 5 as well. All right, there's half of the chart filled out. Questions so far? All right, let's get into it here then. On your laptop, we're going to start looking at different cross sections. For a cube, I want to know what shape is made when I slice it parallel to the base, perpendicular to the base, and diagonal to the base. Here on the left menu, you have all these different types of figures. Cubes, spheres, pyramids, prisms. We're going to do cross sections of a cube for the top row, so let's go ahead and select cube. Exploring sections of cubes. Drag the red points below to see different sections of a cube. What's up? Yeah, I posted it. I'll put it up on the screen here later. It should be. All right, I can move these red points around. When I slice a cube, parallel or perpendicular to the base, what shape is made? Square. Isn't it made up of squares? So wouldn't the cross sections have to be squares? Parallel or perpendicular looks like a square. How about diagonal? If I move these points around and slice it diagonal to one of the sides. This one actually has lots of different answers. Diagonally speaking, you could create lots of different cross sections. Here's an example of one of them. Let me restart here. What shape is this? It's kind of like a rectangle to me. Let's see what the answer key said. Oh, they said you could create a hexagon when you slice a cube diagonally. Let's see if I can make that here. There's the hexagon. When I slice it diagonally, it looks like a hexagon is created.
The hexagon, the shape has 6 edges.
Mm-hmm. There are many answers here. Many options or many answers. The parallel perpendicular cross sections have specific answers. The last column will have many answers. What's the next row? We're looking at a cylinder next. So I'm going to select a new shape, sections of prisms and cylinders. Within this option, I could do a rectangular prism, a triangular prism, or a cylinder. Let's look at the cylinder here. Look at this cylinder up on the screen. You could pull up the same one on your own laptop by selecting sections of prisms and cylinders and finding the sections of cylinders option here. I've got a blue plane slicing through the cylinder. Is it parallel to the base or perpendicular to the base? Why parallel? Two bases are on top and bottom, and I'm between them, right? That blue plane doesn't touch the two circular bases on top and bottom. As I move that blue plane up and down and slice it to find its cross section, what type of shape is it? What two-dimensional shape represents the parallel cross section of a cylinder? To find a perpendicular cross section, rather than having the blue plane running left and right, now I need to have it running up and down, so it's at a right angle with the two circular bases on top and bottom. So let's move this blue slider to the vertical. And now what shape are we looking at? Looking at the perpendicular cross section. Now this blue plane is standing straight up. It forms a right angle with the cylinder and its circular bases. What cross section is made now? What two-dimensional figure can I slice the cylinder into here? It's not a circle anymore. What shape is it? It's a rectangle. It's not a square because it's longer this way than it is this way.
Isn't this column just going to be the bases? Or the parallel ones? Is it like a parallel?
Yeah. Yes. Because you're just stacking that same base figure up the entire way for the figure. Yep. And for a pyramid, it's going to be a triangle, depending on how you slice it. Now, to get the diagonal cross section, let's just find somewhere in the middle. Once again, these diagonal cross sections have lots of different options. Well, what type of shape is that? Oval, an ellipse, kind of like the track oval outside, yeah? There's lots of different options, depending on where you slice it, at what angle. This would be a shape with one edge and one curve. Same shape down below, but if you slice it from left to right, that looks like an ellipse. I'll let you guys start working through the rest of that handout. Find the three types of cross sections: parallel, perpendicular, and diagonal, for the remaining figures. Guys, since you're getting back in here, we're just using that